I'm looking at question 16 from the Maths Methods 2023 paper, Tech Active. So, question 16. A particle is moving a straight line. We've got the velocity here, and we want to find the initial position of the particle. So obviously we want to integrate. Now when we look at this equation, we don't have the techniques to integrate when we have it in fractional form like that. So what we need to do is look at if it fits the form of f dash x over f of x, and then we can then know that the integral of that is ln of f of x. So looking at that bottom part, we've got 6 minus 5 cos of 2t. When we do the derivative of that, we would have that 2 come out the front. We would have the minus, so the 6 would go. The minus would become positive because cos goes to negative sign. So we would end up with 5 times 2 is 10 sine of 2t. Now looking at that top, we have 20 sine of 2t. So basically we've got 2 lots of the f dash x on f of x. So we would want to do 2 lots of the integral of f dash x on f of x. So then that would be 2 lots of ln of f of x, where our f of x is ln, we've got 6 minus 5 cos 2t. Then we're told another piece of information, because obviously we would have a plus c there, should put a plus c up here. We need to find the c. So we're told that the initial position, so at time 0, it's 6 meters from the origin. So we would have 6 is equal to 2 ln 6 minus 5 cos 2 times 0, so that's 0 plus c. When we put that into our calculator, that'll come to a 0. So we get 0 plus c equals 6. Therefore c is equal to 6. So then our equation is going to be, for our position at t, it will be 2 ln of 6 minus 5 cos 2t plus 6. So that's our equation there. Then for the second part of the question, we want to determine the percentage of the particle when it first reaches maximum velocity. Now we have an equation for velocity, so we can use that to find out the maximum. So if we put into our calculator our 20 sine 2x divided by, and I should put an extra bracket there, sorry, divided by, open bracket, 6 minus 5 cos 2x, and graph that, we can then find out the first time it gets to a maximum speed. So the first time it gets up the top here, so we can do our maximum, and seeing that that's between like 0 and 2 there, I can say look between 0 and 2, and it tells me that that is at 0.2928419 seconds. So first at max velocity. So then I can use that time to sub into my equation for position to work out where it is at that point. So I can then put that equation into my calculator, the 2 ln of 6 minus 5 cos 2x, and I'll just put another bracket there, plus 6. And when I graph that and do my second trace 1 and put in 0.2928419, I get an answer of 7.2122664, and that will be meters from the origin. So remembering to make sure you, as you go, you are explaining what steps you use. I'm just showing you how to do these here. And then you would answer the question saying what the position is relative to the origin. Okay, question 17. We've got that model bridges were constructed for a competition. The models that could support the heaviest loads before collapsing were given awards. The load results of the competition were normally distributed. Keyword there. We've got a mean of 1.36, standard deviation of 0.12, and there's 3 award categories. Top 15% get honours, then the next 15% get a distinction, and then commendation for the next 15%. So putting that into a diagram, we've got our mean here at 1.36 kilos. Then we are saying that the top 15%, they're the ones that get honours. And then we've got, if we go 15% down, they're the ones that are going to get the distinction. So that means that part is the top 30%. And then if we go another 15% down, they're the ones that get the commendations. So that means we've gone down 45% to get to there. So what we're wanting to find out, because they said that the model bridge constructed by Finley only just missed out on a commendation, so he's just lower than the top 45%, and Kirby's just missed out, only just qualified for honours, so just on that cutoff for the top 15%, you want to determine the difference to the nearest gram. So what we can do is use that on our calculator, using our second inverse. So our inverse norm, and we can put in there the area we want to find out, that first the top 15% and find out what that value is. The mean of 1.36 and the standard deviation of 0.12, and telling it to look at the right tail, and we get 1.4843. So that was Kirby. And then we need to find out for Finley. So we're going to do the same thing, but we're going to look at the 0.45. So I can go across here and just change that to 0.45, or enter it into the main page bit. And I get, for Finley, got 1.375. Now we want the difference between these two, so then we just want to do our 1.48, and I'm just grabbing that number from there, taking away that one, and I get 0.10929. Now that is kilograms, so obviously I want to times by 1,000 to get to grams, so I get 109.29, but I want to go to the nearest gram, so I'll round that to 109 gram difference.